Well, thank you everyone for being with us this evening. This is the second event in our Encode Near series. It's an introduction to Near. Last week we had our introduction to blockchain, and this week we're going to go a little bit more in depth about Near itself and specific, still staying fairly general and not getting too technical in order to kind of help your understanding and journey. We are Encode Club. We are a Web3 education community. We help you learn, build, and hopefully get hired and funded. And we do this in collaboration with fantastic protocols and by organizing, we hope, very good programming that you will enjoy. Please do make sure you join the Discord, but also make sure the link is there. It's a good place to follow everything that is going on. This series is a three-part series. This 8-event education series, following that, a 2-week coding bootcamp, and following that, a 4-week hackathon. So lots of stuff in store in that respect. In terms of the events coming up, this week we have the intro to last week we had the intro to blockchain event. This week, as I say, intro to Near. The technical overview of Near is on the 7th of December. On the 14th is the non-technical involvement in Near events. Then we fast forward through to January and have both the building on Near events in the 11th and the 18th. On the 25th, we have a What's to Build on Near event, and on the 1st of February, a demonstration of products. So lots of good things to come. In terms of the bootcamp and the hackathon, the bootcamp will be announced soon. This is a kind of gone back too far. This is an in-depth kind of coding bootcamp that will be advertised soon for you to kind of join and kind of to build your first application on Near. And the hackathon itself will also be happening, I believe, towards late January, early February. Let's go into it. Well, last week we obviously talked about, let's remove Lionel Messi up there. Last week we obviously talked about what is Near, and these slides are available on the Medium, which I'm sure Vanessa will put a link to. And we talked about just in general, what is blockchain? What are the concepts? What should you know? This week we obviously go into a particular instance of it, which are the partners, the sponsors of this program, Near Protocol. And in simple terms, Near is a blockchain. It is like Ethereum in that respect. It tries to improve upon Ethereum, and you can do smart contracts. And we're going to talk about the differences, the innovations, maybe even the deficiencies as well today. But in simple terms, it's a blockchain. And this means it has all of the features of a blockchain. So it's effectively a distributed ledger, a database that allows you to do some computation on top of this based on movements of something of value, of tokens. These smart contracts allows you to build decentralized applications, dApps. They are decentralized in that anyone can participate in them, anyone can earn rewards. I guess that's more permissionless, but no one really has control over it. The only thing that really has control here is the code itself. Essentially resistant, no one can stop you taking part in a blockchain. And obviously, as I say, at its most basic level, it is a database, but really at its highest level, it's a global computer. And you can start doing, if you combine all that computational power and you combine all of that, all those actors being involved, you can start to do very good things. But I suspect most people here broadly know what a blockchain is, or at least know what it could point at one, could say, give an example of one, even if they couldn't explain it in depth. But last week we introduced blockchains in general. I added this definition today, which is kind of what I've already said. But just as a definition that we're going to kind of build upon today, we're going to define a blockchain as an irreversible distributed ledger, which combines aspects of computation and data storage. That's a nice way, in general, to think about it. And also Near is trying to improve upon Ethereum, and I'm sure many people here could already already kind of work out some issues with Ethereum. One of which is it's expensive. A transaction fee can cost you hundreds, thousands in the worst case. As a result, therefore, it's slow. It kind of struggles with scalability. It still has proof of work. For those who know what proof of work is, we'll go into that a bit later. Obviously, in the good respects, it's incredibly resilient. Like lots of applications are built and work on it. The infrastructure is there, the tooling there. It seems to be a fairly smooth developer experience as well for that reason. or for associated reasons, because people have built lots of stuff. It is where it is very, very valuable as well, which cannot be underestimated. So to understand NEAR, you first kind of have to understand what Ethereum is doing. And what the difference really between NEAR is kind of this two factors. One, and which we haven't talked about with Ethereum, is usability. So on both how easy is it to build stuff, and second of all, how easy is it for a user to engage with the particular blockchain. And on Ethereum, it's actually quite hard if anyone's like used a wallet before, like setting up MetaMask, setting up Ledger, doing everything. It's not the most intuitive, and you realize how unintuitive it is. I think one forgets how unintuitive it can be until you explain to someone else and try and help someone set up their own Ledger and their own MetaMask and their own wallet, and you kind of see how clunky the process is. So regardless of the technical specifics, there's two things NEAR is aiming at, which is to improve on usability, make it cleaner, more natural, and focus on scalability, making sure that you can run bigger blockchains that are fast and that don't have the fees. And gas in Ethereum is effectively not a tax, but almost just a tax on usage. Like it's like a congestion charge in London or in a city. It's like there's only so many roads, and you can only safely go so fast on those roads. And if you've got too many cars, like you eventually have to do something to either limit it or basically limit it or collect money to improve it. And that broadly is what a congestion charge is. It's a charge on usage to both tax using a car. Okay, in this case, the analogy is clunky because we don't want people to use cars. We want people to walk, cycle, take public transport. But it's effectively a tax on usage because there's only so much space you can use, and therefore you want to work out someone's desire to work based to desire to drive, in this case desires to do transactions based on price. The issue is Ethereum is a very small city in that respect, or a very slow city, and these transaction fees get very, very high because there is constant demand for doing transactions. So usability and scalability are these two kind of main things here. The other difference about NEAR is it uses proof of stake, and we'll go into this a bit later. But broadly, all we need to know for now is what proof of work is, which is what NEAR and Bitcoin uses. And broadly, we're talking about a consensus mechanism. So a way to decide and tell everyone that there's been a change to the ledger, to the database. If this was money, if this were banks have systems, backs, chips, chaps, all of these things that you're kind of very used to using or very used to hearing are ways banks settle payments between each other. Effectively is a spreadsheet, and that spreadsheet is unofficially kept by a central bank in some respects. Obviously, with the blockchain, we try and replace this with a consensus mechanism. That means everyone can run the code, and we can agree technologically what the state of affairs are, with incentives to make sure people are good actors. Now, in the case of Bitcoin, use proof of work, which basically says, in order to get the chance to verify a transaction and tell everyone and get the reward associated, we first want you to do this very effectively energy costly task of solving a maths problem effectively. And if you solve it, we'll give you the opportunity, we'll let you, if you solve it fastest, we'll let you mine that block and get the rewards. And what this does is two things. One, if you've got a lot of computation power and a lot of energy, you are incentivized to do this problem and get the reward. But it also means you have skin in the game, which means if the later the consensus mechanism figures out that you were a bad actor and were running the wrong code or telling a blockchain the wrong thing, that it will then punish you. You are punished because you won't get that reward. Now, this is an inefficient system because it's energy intensive, which means cost intensive, but mainly energy intensive. And innovation and Ethereum is also going for this, is instead of making people do this kind of inefficient task of doing a maths problem, why don't you, which is basically a reputational stake, you're staking your time when time is denominated in money, why don't you stake actual money? And if you're found to be a bad actor, you lose that money. This might be a better way of doing things. So this is another thing that's different. It also uses this thing called sharding. Now, sharding is broadly the big innovation, and to when we're understanding sharding, we should also understand some of the backstory to Near. And some of the backstory here is that Near was invented by some very smart mathematicians, and it was at the time when Ethereum was still very slow and still very expensive, and we were particularly looking at other layer ones. The innovation they had was sharding. This is like broadly what they want to do different, make it more usable, but make it more scalable by sharding. And sharding is basically the principle that not every node has to run all the code. So currently with Ethereum, every node has to run all the code. So every node, it takes a lot to run them. Like it's not just something you can run off your computer. You need like quite a big heavy duty kind of unit, and you have to optimize a lot for the energy efficiency of that unit. And to do it at any scale, you need a big area. Like this is cumbersome. Sharding, what it does is rather than having the network so everyone has to run the code, we basically split the computation into little chunks, little shards, and have them done in parallel. So rather than having like, we'll mine this one thing, then we'll mine the next thing, and then mine the next thing. What if we could mine lots of things at once and fit these back together? I'm not going to, this is more, the in-depth of sharding is for the technical workshops coming up. But in general, this is it. So rather than having stuff done in this linear manner, can we split everything up and perform computation in parallel? And this, again, there should be no limit, because then it's your network capacity is linked to the number of shards you have. And then each node could be responsible for a particular shard, or a set of nodes could be responsible for a shard or a set of shards. And this is good. Like it's a hard technical problem. It's not all the way there, truth be told. And other people are trying to do versions of it. But if it is achieved, it is game changing. So that's the first thing. So sharding is this big kind of different innovation. Next about Near, and maybe this isn't different, but because every community has its, every community kind of has its, or every protocol has its community, but the Near Collective is, I think, particularly strong with lots of DAOs and guilds and members and community funds. And I think it's quite sophisticated at this point. So you should go and check it out. And this is something to be noted about Near. The other thing is we should talk about the Near token. So obviously a token is how people, oh my God, where's that moving? At broad extent, a token is how people use applications on the network. Or how people pay for stuff on the network for when they submit transactions. And this methodologically is, I'll answer, yes, it is. Like, actually, I'll just start there because there's some crucial questions. First, the recording go up tomorrow. Second, it's not a fork of Ethereum. Third, it's not EVM, but there's an EVM bridge. It's not EVM compatible. Yes, it is like database sharding. And I don't know how many nodes there are on there. Should we find out? Let's look at the Explorer. Oh, that was really easy. 129 nodes. So you could also argue there should be more. And you can make that up. This is the Explorer, by the way. It's where you can see all transactions. This compares to, like, on Ethereum, you'd have something like Etherscan. Cool. Keep questions coming if you have them. So that's the wrong presentation. We use a token to basically pay for usage of applications. It's like a VAT in that respect. And we pay it to Node to actually run the network, tell the network what's going on. And this is a normal change to development. So like if I go to Facebook, what is happening is that they are paying for the costs of hosting it and running it, or Facebook are, and then we are doing something on Facebook, which doesn't necessarily have to be a charged activity. It could just be scrolling using social media. In blockchain development, this is not specific to Near. We flip it. So when you use an application, you pay a fee, and the applications are owned by also by the users, by token holders. But crucially, when I do a transaction, and we know this, I pay for it. I pay for the fees of doing so. This is a big change, and you can do the opposite in Near. But this should be noted. Again, not as specific to Near, but this is why something like Ethereum, what the economics of that token are as well. It's the token by which stuff is, you pay for stuff to do you pay for oh my god, my brain is such mush at the moment. You're paying the network for the ability to run transactions, and that mainly falls on the users, though there are deployment costs as well. Why is I've frozen? Wow. Okay. In terms of running a node, so running a node means being like the person validating transactions and telling everyone. If we go back to Explorer, being one of these guys. This is permissionless. It's always permissionless. Anyone can do it. You can download the code, you can run it. We can go here and go, oh my God. We can go running a near node, and you can just download the code and you can do it tomorrow. Now, why wouldn't you maybe do that? Well, it's quite expensive to do. So, and you might need, like, to do it at scale, you might need a lot of computing power. So, like, maybe it's not worth doing at home, but it's worth kind of trying for fun. Anyway, because Near is permissionless, anyone can run it. And in doing so, you earn a share of the transactions fees paid. And the mental math you want to do is, will the revenue I make on transaction fees be greater than the cost of running the node in terms of both time and like physically running a computer? To check nodes good actors, we require them to stake. This is the proof of stake thing I mentioned before, which is broadly you're just putting money in escrow. And I wonder if we can, I hadn't actually prepared this, but I wonder if we can, oh, brilliant. So now we can actually visualize it. So here we have number of nodes. We can have the name of the nodes as well. So like this is a Binance one, this is Electric, this is an Aurora one. Tottenham Hotspur one. What the hell? That is, I'm actually Googling that. I'm an Arsenal fan. I want to see what that is. What the hell? I'm so confused, guys. Anyway, so we can see broadly where the node is. So this one's in Antarctica. Somehow I don't believe that. Maybe it is. Is it active? What percentage fee it's getting? How many delegators people basically who have near tokens? I'm going to move this down because I want to slump. How many people have near tokens that want to give it to this node to run on their behalf and then share the fees? And what they've staked. And obviously, if you've got more stake, you've got more reputation, and you're kind of more likely to get the chance to validate a transaction. So yeah, we can. There's 43 million. So this is a big dog. Let's see the smallest one. So, I mean, these aren't active nodes; they're idle. Smallest active node has 3.5 million near, which is quite a lot. The near price right now is 8-ish, 9. So let's go back. So the minimum that the one has is about 27 million dollars worth. The fee, I actually don't know what the fee is. I think it is. I have no idea in this case what the fee is. Sorry, forgive me. Forgive me indeed. Right. So you have required stake, and obviously the stake is worth a lot of money. And if you are seen to be a bad actor, you make a mistake. You reveal the wrong information to the network. Some of your stake will be slashed, and I guess in theory all of it could go, which you obviously don't want. Again, it's a lot of money. This is what happens. You might be like, so how does it figure out? Well, the system doesn't just rely on one person to tell the network. It comes to consensus. So it gets lots of people to kind of verify something. And if, like, I don't know, X percentage verifies and comes to consensus, verifies something's happened and consensus is reached, you can go back and be like, well, who didn't agree? And then use that to try and determine, identify who was running improperly. SI is telling us, fee is percentage of the validated text before giving back to the rules to delegates. That probably seems right. I just wasn't sure. That's probably seems right. Okay, so in general, this is like the 10,000 foot view. We have a token. We have this thing called sharding, which is doing a bit different. We're trying to focus on usability. Let's actually have a look at what I mean when I say usability. So I can go to a near wallet. I'm actually going to do this on a slightly different browser so as to not dox my own wallet. Anyone got any questions while I can't use my mouse? Which process, David? Yeah, we can have a look. Yes, I can try and show. I know. Well, it's not. It's just it won't charge. I think it honestly only needs like 30 seconds to give me like a couple hours of usage. But like, I'm going to give it a couple more seconds. Anyone have any? So we can look at validates delegate stuff. Anyone have any other questions or things they want me to show? I've got a few more things up my sleeve, so don't worry. Right, just show you the near wallet. If you want to go and set up and use it, it's like very smooth, buttery smooth. So I'm going to create a fake wallet. Can everyone see my screen again? Drawbacks, it's really hard to do it properly. That's the main drawback. It's like, we could do something much more efficient. Should we do it? Well, yeah, but like it's really hard technologically. That's the issue. And to make sure everything is actually in sync if you're going to have everyone doing stuff at the same time. So I'm just going to show you how you create a wallet. Let's do test encode event.near. I bet no one's had that one new. And I can choose if I want to back it up to a ledger, which is hardware device, or secure phrase. I'm actually not going to remember the phrase for now. I'm not using this wallet. No one likes to steal it. Oh no, I forgot what the phrase is. Cool. And then I can choose to receive a one-time verification code. And then I need to make an initial deposit, and that's it done. Like this is like very nice. So let us I'm going to get a verification code to a test email. So let's get that. Let me get that. So anyone that watched my graph event will know I'm not doing well with demos recently. There we go. It's come through. I bet it's going to reset now. Are we cooking on gas? It doesn't look like it's going to make it. Come on. Yes, and I've got a wallet. This is it. It's done. And if any of you compared to like an Ethereum wallet, like, oh wow, it gave me a little bit of near just for existing. How nice. It's like the count number is words. It's quite nice. And I can have NFTs straight in, like a very like buttery, nice UI. And this is because Near's focused on usability, and this is a good thing. So please go and create a Near wallet, and they will give you a little bit for free. Only 5 cents, but like, come on, 5 cents isn't nothing. Look after the pennies, the pounds, and look after themselves. So going back to there. So that's a wallet. It looks really nice, and this is a lot of the experience on here. And when we get into some of the creating apps, you'll kind of see the same principles broadly apply. Next, in terms of if you're a developer in languages, so Near runs WASM, so WebAssembly, but you can just do your smart contracts in TypeScript or Rust. Actually, I'm going to try. It's a very nice. Oh, I might not have it to hand. I thought I had it. Okay, don't worry. We will. By the way, here's all the code for running a node for anyone who wants to have a look. So we won't do that. But anyway, you can write it in TypeScript, which is very much like JavaScript. Sorry, you can see I added the all Rust bit very late. That is completely poor grammar. You can write it in TypeScript, which is a modification of JavaScript, or Rust, which are very obviously for anyone that's done either of those different languages. In general, we've got lower gas fees as a result of sharding. The scalability here means lower gas fees, which is a good thing. And we're trying to make it faster. So faster kind of time for blocks to produce and faster for them to be kind of final. Other cool things about Near that are a little bit different to Ethereum. So senders only pay gas for the gas they use. It's capped quite well, which is a good thing. You can prepay gas. This is actually innovation that some startups in the Ethereum space are actually trying to do. But you can prepay gas for your users, which I think is kind of important. Oh my god. Because what you want to ultimately have is a world in which you engage with applications and don't have to, you sign in with a wallet, but don't have to worry about gas and for everything you do to be a small cost. You want it to kind of happen in the background. And actually, a very good example of this is If anyone's used Sorare or Sorare, whatever it's called, the football game on Ethereum, you never realize you're doing something within crypto, or that all the assets are NFTs. It's all kind of abstracted for you. I already talked human readable accounts because they're quite cool. And obviously, it's basically the equivalent of ENS in Ethereum, but it's every account is like every account is an ENS is already named. And the other cool thing is the Rainbow Bridge. So earlier, we'll spend a few minutes talking about this. Earlier, we talked about Ethereum, or someone mentioned Ethereum. And the Rainbow Bridge, this is such a complicated thing, but broadly, it's best to kind of show you, is moving assets from Ethereum to Near. So the bridge is called Aurora. And basically it says this: let's say I have an NFT on Ethereum. I lock it up at one end. At the other end, it's like a it's like a teleport is the best way of thinking about it. So I go in at one end, and it's actually teleport is a terrible way of thinking about it. I go in at one end, I take my asset, it's locked up. On the other side, it mints a new asset, which is a Near version of that asset. So like say I had ETH on one side, but I wanted to use ETH on Near. I'd lock it up, and what would immediately be minted is N ETH, like Near Ethereum, that could be used and is the same token standard of other Near assets. And then if I want to go back, I lock that N ETH back, and on the other side, my Ethereum is released. So you lock something up that gets something released. You lock something else on the other side, which gets the other thing released. And it's to basically make sure that you can have equivalence of tokens between different chains, in particular between Near and Ethereum. And that's kind of cool. And here's on a technical level how it's working. You see, you've got a token locker and then a mint to fundability bit, and a token locker and a minting fungibility. Mintable. Sorry, I got that wrong. You can't yet do NFTs. NEP21 is the equivalent standard of the ERC20s on Ethereum. Anyway, this is kind of important because obviously there's a lot of assets on Ethereum and we want to use them on Near, and there's going to be a lot of assets on Near and we want to use them on Ethereum, and we don't want chains to be a blocker to one another. So this is kind of extremely important, and it's not EVM compatibility. It's not like you can build smart. You can't run Ethereum smart contracts on Near, but it's moving towards a kind of more multi-chain world where different protocols interact, and maybe different protocols are specialized to do certain things. My voice is going now. Forgive me. The Rainbow Bridge has got prettier, but this is an example of it. I'm not going to have sound. So on the one side, you've got Rain, and we want to this is paying on MetaMask, a transaction fee, and we're trying to print out mint at N Rain on the other side. So the bridge itself is called Aurora. Okay, it's waiting for blocks to sync. We're verifying transaction, telling everyone. It's effectively two transactions here, one happening on the MetaMask side, on the Ethereum side, one happening on the Near side. And now it's transferring to a particular wallet. This is on testnet. And there it's done. We have moved an asset. We have moved 10 Rain from Ethereum to be 10 N Rain, which are equivalent on Near. This is very cool indeed. And again, lots of cool stuff we've done, particularly in hackathon around this. Oh my God, I keep going back to that presentation. No, go away, video. Other things to show you. So an Explorer is a way to explore transactions. I used it to show the validators, the node runners. But I can look at all transactions. It's not quite as in-depth as the Etherscan. Maybe that's a good thing. But I can see all the transactions happening. I can see all people's balances. I can see a list of what stuff's going on. I can also see the code, which is great, which is obviously important. So we have full transparency of what's going on in the network. But do head over to Near Explorer if you want to kind of take a look. I always think it's worth taking a look under the hood of a blockchain and just seeing what's happening. Why it's happening, what frequency of stuff's happening. My voice is very much going, so I'm going to stop talking in a moment. And I've already mentioned the docs. I've kind of drip feed them drip fed them in throughout today's workshop for you to kind of have a look at. My voice is completely dying, so that's a good point to stop and take questions. This has been a kind of whistle-stop tour, just an overview of NEAR. The key thing I think to take away, if we go back on slides, is this focus on usability and scalability. Ultimately, lots of blockchains try to do different things. NEAR is trying to focus on these two things, make it a more buttery, smooth, clean experience for the user, and make it more scalable with sharding, which we can go into a bit more depth next week. In terms of next week, more of a technical overview next week. And then we go into a non-technical event after that. And after Christmas, we get into the building events as well. That's all for us for now. What questions do people have? I'll try and get out that stuff about delegating and validating for you, David. Where is it? I'll turn screen while looking for that. Any other questions? When Gunners, I honestly, that has like baffled me. I'm so confused. So you can delegate your stake straight on the NEAR wallet, which is beautiful. Again, this David, this is David, is that in general with NEAR or general with blockchain? Because the NEAR docs are actually amazing. So go here. You should also go back and watch our event last week. You can look at the slide. It's my general intro to blockchain. But this is towards the bottom of that page. I'll just share my screen. Is loads of amazing resources. As I was preparing this presentation, I went back and read everything, and I highly recommend these. I think NEAR's plan, Brian, is broadly that like you want to have the NEAR wallet as a very clean experience, and to have lots of applications built with it, simple as, and there are, and they've gone heavily into DAOs particularly. So it's the same as the Ethereum Web3 vision is build applications and build internet applications that are all protocols that are governed by their users, and you engage them with them through a Web3 wallet like the NEAR wallet. Yeah. Any other questions, guys? So if you have, what I recommend is you copy this chat with all the crucial links before we finish. I'll leave the room open for an extra minute to do so, because we will put them on afterwards tomorrow. But I'm going Vanessa, worth making a note of that to make sure all the helpful links are in there. So yeah, other questions? Yeah, that's kind of a simplification. Yeah, obviously there are some specifics and different approaches, but like, yeah, I guess so. But again, they have taken very different design decisions. But yeah, in those general terms, yeah, I guess so. Okay, guys. Well, thank you very much. I'll keep the room open for a minute so people can just make sure they get all the links, etc. See you next week for more of a technical one. In the meantime, if anyone wants to drop me an email, go direct on here. I'm a bit slow on Discord. I kind of get lost under the melee of messages. But if you want to drop me an email, I definitely read every email. All right, guys. Thank you very much. In the meantime, have a wonderful evening. Thank you for your attention this evening. And I'll leave this room open for a minute for you to get links. But have a nice evening and see you all soon. Thanks, everyone.